Hey, I'm Meyer, and this is my charge tape lab. Starting off with our purpose, that was to investigate the principles of charge and electrostatic interactions with household items. An overview of the lab, we first employed an experimental model by creating two charge tapes and observed the interactions between those, our hands, and other objects. We then also developed a computational model to simulate our interactions and calculate certain defining principles. Those principles included Newton's second law, observing a system's change in momentum over time as proportionate to the net force applied, Coulomb's law, which describes the attractive and repulsive electrostatic forces between two electrical charges, and gravitational force that describes the force between any two objects with mass. The subsequent results we will get into a little more detail later, but our findings included that the U tape is indeed positively charged. The charge on each tape is 3.172 times 10 to the negative eighth coulombs, and then our deficit of electrons was 2.321 times 10 to the sixth. Going more into how we applied those aforementioned principles to derive our findings, Newton's law gave us a theoretical framework to observe our two tapes, as we know that without a net force causing a change in momentum, we would not see any change. And with our motionless tape, we then use this in concurrence with these next two ideas to set the gravitational and electric force as equal in magnitude and opposite in sign to each other. So using this basis of Coulomb's law, we were able to calculate the charge of one tape. Additionally, treating the tapes as point charges allowed us to derive the electrical force using the electric field formula. Gravitational force, as mentioned, would have been another vertical component force upon our tapes and allowed us to calculate and represent what our electrical force was. So going more into our assumptions now, we had to make two key assumptions to translate our experimental model to our computational model. The first was that each U-tape has the same net charge, allowing us to calculate and translate force between these tapes, as shown in the images on your left, kind of right here. The second was essentially that each tape acted as a point charge, allowing us to compute our charges further, extrapolating in flow script. And going into our experimental procedure, we first learned how to create a single charge U-tape, then repeated that process to create a second, and had to do a series of experiments that basically gave us the observations we'll now look into right now. So basically, we found that our U-tapes were positively charged, and that they repelled against each other while attracting other negatively charged objects. So we were told that the pen, for example, when rubbed against wool or clothing or something, was negative, and that attracted the U-tape, giving an indication that the U-tape was positive. Same thing with our hands. And then, yeah, when we tried to put two U-tapes close to each other, they repelled each other. So that kind of supported that idea. And doing that, we found our distance to be 0.631 meters, which helps us into our initial conditions that were used in our computational model. So some more of those included these right here that you will see appear basically in just a second. Yep. So including our Coulomb's constant, what's it called? Our, sorry, our electron charge constant, atom length, and things like that, as well as our conditions that we found right here. With that, we were able to um, calculate gravitational force and apply that to our electrical force because of our assumption that that explains a motionless object under Newton's second law. We were also able to calculate the number of electrons, basically reversing our electric force equation, but using gravitational force because that's what the real number was in our code. And then also calculated the area of the tape and found the total number of atoms in our tape because of that, and also got the ratio of electrons to the ratio of atoms in the tape. And then in part two, we basically just calculated the real magnitudes of electric and gravitational force between the tapes, away from the ideal system with our initial conditions. Saw that they did in fact differ, and so we can go a little bit more into why that may be so. So basically, the assumptions that we had in order to make our computational systems probably weren't exactly true. There's probably an unequal distribution of charges on the tape and a loss of charge due to handling and our variability of our environment, like humidity and things what were mentioned. The U tapes are also not point charges. Using something like a line charge model would probably be more accurate, and things like air resistant, hand force, and horizontal forces are not negligible outside of a vacuum. And so discussion, if we inverted the charges, we would probably not see any differences in observations, as the charge shapes would then be negative, repelling each other while attracting the positively charged objects now. And then in terms of the two models, like we just said, the line charge model would be more accurate to the real value, as it takes the lengths and characteristics of the pieces to tape in mind, having a more accurate number of electrons, and then also the charges with that. Yeah, thank you.